how do we multiply fractions? Straight across. Oop, let me fix that. So we're going to multiply 3 times 5. And we're going to multiply 4 times 7. 3 times 5 would give me what? 15. And 4 times 7 gives me 28. Can 15 over 28 reduce at all? No. The only way to get 15 by multiplication is to do what? 3 times 5, or the other possibility would be 1 times 15. 3 doesn't go into this, 5 doesn't go into the bottom, 15 doesn't go into the bottom. So I can't reduce it at all. That would be my final answer. For the second one, what do I multiply together to get the top? 4 and 3. So I do 4 times 3 on the bottom. 5 times 2, so that's going to give me 10. So I have 12 over 10. Can that reduce at all? Is there anything that would go into both the top and the bottom? 2. I can rewrite 12 as 2 times what? 2 times 6, and I can rewrite 10 as 2 times... When I have a common factor between the top and the bottom, that will cancel out. So fully reduced, my answer to this second one would be what? 6 over 5. So for multiplying fractions, we multiply straight across. We'll multiply top to top, and then bottom to bottom. And then reduce if we can. Dividing fractions. So for our last one, there are 3 words that help me remember how to divide fractions. First of those 3 words is keep. Has anybody heard this before? Keep and then change, and then flip. Keep, change, flip. So what that means is my first fraction, I'm going to keep this one. So that's going to stay 1/2. We're going to change the operation. It's going to change from division to what? Multiplication. And then this last one over here, the second fraction, we're going to flip. What does this look like if I flip it over? 2 over 1. Now it's a multiplication problem. So now I do it just like the multiply. I'm going to multiply top to top and bottom to bottom. What would I have up on the top then? 2. On the bottom? 2. Can I simplify that at all? Yeah. We get 1. We have a common factor, top and bottom, so it cancels out. And when we cancel through division, we're left with 1. So far, so good? You guys remember doing this? Yeah. Cool. Grab your notes packets. We did page 3 yesterday in there. The pages are numbered. We're going to be on page 4 today. If you don't have a notes packet, because you weren't here yesterday, you can grab one up at the front. Notes packet is on the bottom, all the way at the back. And that paper on top is the homework from yesterday. I don't know if you grabbed that already. Okay.
So we don't use our book anymore, right?
Yeah, page 4. Should look like this right here. We're going to learn how to simplify rational expressions. A rational expression is a ratio of two polynomial expressions. A ratio is also a fraction. Ratio, fraction, proportion, those are all usually used interchangeably. The same way I can simplify a fraction by seeing if there's something that'll go into both of them, and if the same thing goes into the top and the bottom, I can cancel it out. And what I've got left would be my reduced or my simplified answer. We can do the exact same thing with rational expressions. Rational expressions are where I have a polynomial on top and a polynomial on bottom, but that's set up like a fraction. I want to find the factors of my numerator, just like I found the factors of 35 up here. And I want to find the factors of my denominator, like we found the factors of 45. That's not 8, that's 9. Good grief. I just caught that typo there. Factors of 45 are 5 and 9, not 5 and 8. If we have a common factor, top and bottom, we can cancel them out. And then whatever I have left over would be my fully simplified answer. This is why we spent yesterday reviewing factoring, because we're going to have to factor the numerator and we're going to have to factor the denominator. Let's look at example number 1. Still on page 4. We're going to have to factor both pieces. All right, so let's come off to the side. We're going to factor the top. My numerator up there is x squared minus 2x minus 24. When we're factoring, what's the first thing we always look for? GCF. Do we have a GCF in our numerator here? Is there anything that goes into all 3 pieces at the same time? No. No GCF there. So if there's no GCF, what's my next step? We're going to make an area model. What else are we going to do? We're going to label ABC. What is my A? What's the number that goes with A? 1x squared. So even though they didn't show me the 1, it's a 1 for my A value. What's my B value?
2.
Negative 2. Remember to take the sign in front of it. And my C? Negative 24. So I'm going to draw my area model, my box. A always goes in the upper left. C always goes in the lower right. So I have x squared here and negative 24 down here. How do I decide what to fill in those 2 empty boxes with? Do the x thing. What do we put up on top? A times C. What was the number for our A? 1. What was the number for our C? Negative 24. What do I get when I multiply those 2 together? Negative 24. What goes down on the bottom? B. What was our B? -2. We need to think up two numbers that when we multiply them together, we get -24, but when I take those same two numbers and add them, I get -2. I heard -6, and what was the other number? +4. -6, +4. So I'm going to put that in here. It doesn't matter which box they go in. But what do I have to put with each of those numbers? X has to go with each of those. And then we look at rows and columns. Top row, x squared and -6x. What can I take out of both of those? I can take an x out of each one. What about the bottom row, 4x and -24? What's the biggest thing that'll go into both of those? 4. Positive or -4? Positive. How do we know it has to be a +4? It's touching a positive box. The 4x right here that it's next to is positive, so I take that positive out. Then I'm going to look at my columns, and I'm going to do the exact same thing. So first column right here, x squared and 4x. They have an x in common. My second column, -6x and -24. What's the biggest thing that goes into both? -6. How did you know it had to be a negative and not a positive? Because it's touching a box that has a negative. That -6 right there is why I had to pull the negative out with it. All right, so my numerator, when it's factored, is x plus 4 times x minus 6. Those are the things that if I multiply them together, I get that original numerator. Now we got to do the exact same thing for the denominator. So let's factor the bottom. My denominator, 2x cubed plus 6x squared minus 8x. Does that have a GCF? Yes. Be careful here. What is the GCF? 2 and x. Every single term can be divided by 2, and every single term has an x in it. That GCF has to come up here. So then I'm going to take it out of each piece. So I would have 2x. What do I have left if I take a 2x out of 2x cubed? X squared. What do I have left if I take a 2x out of 6x squared? Plus 3x. And what about that last term, -8x divided by 2x? Minus 4, -4. I'm going to label A, B, and C. A is right here in front of x squared. It's another 1. B is 3. And C is -4. So I'm going to draw my area model. And I'm going to do my x. A goes in the upper left. C goes in the lower right. So x squared and -4. A times C, what are we multiplying together? 1 times -4. What is 1 times -4? -4. Down on the bottom? 3. So we need two numbers that when we multiply them, we get -4. But when I take those exact same two numbers and I add them together, I get a +3. 4 and -1. So I'm going to put that in my area model for x, -1x. And then I'm going to pull out my greatest common factors from my rows and my columns. X squared and 4x. X squared and 4x. X. Now on the bottom, negative 1x and negative 4. Negative 1 is the biggest thing that'll go into both of those. X squared and negative 1x. I can take an x out. 4x and negative 4. I can take a positive 4 out. So I got 2 factors from doing my area model. Does that mean the denominator only has 2 factors? I got 2 factors from doing my area model. It has 3 factors. Why does it have 3 factors? Because we had that 2x, the GCF, the greatest common factor. All right, so in my denominator, I have 2x. I have x minus 1. And I have x plus 4. Are any of the factors the same between the top and the bottom? X plus 4 and x plus 4. Those are going to cancel out. So what do I have left over on the top? X minus 6. Since there's only one factor left on the top, I can write it without parentheses if I want. There's nothing wrong if you keep the parentheses around it. How many factors do I have left on the bottom? 2. 2x doesn't have to go inside parentheses, but the x minus 1 does. This would be my fully simplified rational expression. What do we call the bottom of a fraction? The denominator. Down here on this line, denominator. The expression is undefined when the denominator is equal to 0. No, when the denominator is equal to 0. When the denominator is equal to 0, my rational expression is undefined. Another way of saying that is that the denominator cannot equal 0. We don't want it to be undefined. The way I figure out which values for x would make this undefined, which values for x it cannot be, because I would end up with a 0 on the bottom, I'm going to take every factor that I have in my denominator. How many factors did we have in the denominator? 2. I'm going to set them equal to 0. So 2x, that cannot be equal to 0. And x minus 1, that also cannot be equal to 0. And then I'm going to solve both of those for x. 2x not equal to 0. What would I do to get the x all alone? Divide both sides by 2. What is 0 divided by 2? 0. X cannot be equal to 0. If x is equal to 0, then this is going to be undefined. X minus 1 equals 0. What would I do there to get the x all by itself? Add 1 to both sides. So that's going to cancel. So that means x also cannot be equal to what? 1. If x is a 0 or x is a 1, that would make the denominator of my fraction a 0, and that's not allowed. Right. Do you guys see the check problem right below this one?
Yeah.
I want you guys to factor that numerator on your own. On the check problem, factor the numerator on your own. Sorry, one more time. Oh, yeah. There you go. On the check problem right below example number 1, I want you guys to factor the numerator, factor the top, just like we did the top here.
Just like we did the top.
The whole thing or just the numerator?
Just do the numerator for right now. Factor the numerator on the check problem, please. Looks great. Does the numerator have a GCF?
Oh, where? You guys, you know?
Nope.
Oh, it does?
Nope.
You can do 1 by
You can, but if you divide them by 1, does anything change? No. You're not wrong that 1 goes into everything. But when we're talking about our greatest common factors, we usually ignore 1 because it's not going to change anything if I take it out. All right? So no GCF. So I need my A, my B, and my C. What is A? It's x squared. We have a 1x squared for A. What is B? 2x, so 2 for B. And what's C?
1.
Positive 1. C goes down here. We multiply A and C together to get the top. So I'm going to multiply 1 and 1. I need 2 numbers that multiply to give me 1, but add to give me what?
1.
Adds to give me 2.
No, I don't. The answer is
Yep,
1.
it's 1 and 1. So 1x and 1x. What do you notice about when you factor this across the top and down the side? What do we end up with? Same thing on both sides. What do we get? X plus 1 and x plus 1. So my numerator, when I factor it, I have x plus 1 and then another x plus 1. Those are the things that if you multiply them together, you get the top. Does the bottom have a GCF? No. So I get my A, my B, and my C. So 4x squared and negative 1. I'm going to write down something that's wrong, and I want you guys to tell me why it's wrong.
Why do you have a negative 1?
Why do I have a negative 1 there?
It's
It's supposed to be A times C, and all I wrote down was C. What is our A value? So I do 4 times negative 1. Up here on the top, I should have negative 4. Down on the bottom, what do we need this to add to? 3. What numbers multiply to negative 4 but add to 3? 4 and... If I do negative 4 and 1, what happens when I add them? I'd get a negative 3. 4 and negative 1, because when I add those, I get a positive 3. 4x and negative 1x. 4x squared and 4x. What can I take out of that top row? 4 and x. What about across the bottom row? Negative 1x and negative 1? Negative 1. So 4x minus 1 is one factor on the bottom. Four x squared and negative 1x. What's the only thing those have in common? X. What's the only number that I can divide 4x and negative 1 by? 1. Will it be positive or negative? Why is it going to be positive? Yep, this number right here, the 4x that it's touching, the box that it's closest to, is a positive. So I take that positive out. So x plus 1. We can cross out x plus 1 and x plus 1. So what would my fully simplified expression be? It's absolutely correct. X plus 1 over 4x minus 1. Which part do we make not equal to 0? The bottom. Because the top of a fraction is allowed to be 0. The bottom of the fraction is not allowed to be 0. So 4x minus 1 cannot be 0. What would I need to do there to get the x by itself? Add 1 to both sides. So 4x is not allowed to be 1. What else would I need to do to get the x all alone? Divide both sides by 4. So x is not allowed to be 1/4. Or what would that be as a decimal? 0.25. I would accept either one of those. X cannot be equal to 1/4, or x cannot be equal to 0.25. Yes, ma'am. Yes, you may. Yep. Go ahead and flip to page 5 for me. What do you see up in the numerator that we haven't seen before? There's a negative x squared. Does anybody need me to leave this up a little bit longer? Okay. We're going to do it just like we did the others. We're going to factor the top first. And then we're going to factor the bottom. So the top, negative x squared plus x plus 12. The bottom is x squared plus 5x plus 6. Not a trick question, but be very careful before you answer. Does my numerator have a GCF? Yes. It is negative 1. It is negative 1 because when we're factoring, we never want a to be a negative number. Is a negative number right now? Then I'm going to divide it by negative 1 so that it's not negative anymore. I'm going to divide all of these by negative 1. So that negative 1 goes up on the top of this fraction. It's going to be part of my factored form here. What would I have left over if I take negative x squared, and I divide it by -1? I'm just going to have a positive x squared. Is my a positive now? Yes. Now I'm going to be able to factor it. What is x divided by -1? Negative x, so minus x. What is a positive 12 divided by -1? A negative 12. Now I can do A, B, C, my area model, and my x. What is A? Positive 1. What is B? Negative 1. And C? Negative 12. You never, ever, 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 ever want A to be negative, because it'll mess up things when you do your area model, when you do your box. We multiply A and C together. A is 1. What was C again? Negative 12. So I want two numbers that multiply to give me negative 12, but add to give me what? Negative 1. What multiplies to negative 12 but adds to negative 1? Yes, 3 and negative 4. So 3x and negative 4x. Top row, x squared and 3x. What can I take out of both of those? X. Negative 4x and negative 12. What's the biggest thing that'll go into both of those? Negative 4. So x minus 4 is one of my factors. Goes up on top. Let's go do our columns now. X squared and negative 4x. What can I take out of both? X. 3x and negative 12. What's the biggest thing that goes into both of those? 3. Positive or negative 3? Positive, because touching a positive box, the 3x is positive. I want you guys to factor the denominator and write your simplified expression. Factor the denominator. Cancel out anything that's the same, top and bottom. And write your simplified expression. It does matter. That's not a negative 3, sweetie. Negative 3 times negative 4 would be a positive 12. That should be a plus, positive 3. There you go. That makes it a plus right there. There you go. But yes, it does matter when you're doing it. If you had an x minus 3 and an x plus 3, those would not cancel. That's a great question. How did you confuse yourself? I'll be right over there.
A is tree. A still goes with it.
Yep.
Is B still? Because 3 and 2.
B doesn't go anywhere in the box. Those two numbers would combine to give you your B. That's why they have to have x's with them. Put x's with them because they're going to make this.
Okay,
So put an x here and an x here. It's 3x and 2x. Because together you get 5x. Give me just a second. Kaylin had a question first, and I'll be right back.
Right here. When I do I put
click this in.
Yep, leave it like that, and you're done.
You don't do the
You don't
zero?
need to distribute. Oh, doing the zero part you already did. It's
I don't-
only things that make the bottom zero.
Oh.
So do I do like the x equals x plus 2 equals 0?
Equals 0, yes. Do we have a GCF on the bottom here? Nope. So I've got my A, my B, and my C. 1x squared here, 6 here. 1 times 6. I need two numbers that multiply to give me 6, but add to give me 5. Negative 1 and 6 will add to 5. 3 and 2. The problem, and I like that you guys are looking for that though, but that would be if it multiplies to what? Negative 6. All right, so we got 3x and 2x inside those boxes. What can I take out of the top row? X. What can I take out of the bottom row? 2. Positive or negative 2? Positive. So I have x plus 2 here. What can I take out of the first column? They both have an x. What can I take out of the second column, the biggest thing that'll go into both of those? 3. Positive or negative 3? Positive. X plus 3. Can I simplify this at all? Is there anything that will cancel between the top and the bottom? X plus 3 and x plus 3. So what do I have left on top? Negative 1 and x minus 4. Do I need the parentheses? Yes, unless you distribute. What do we have on the bottom? X plus 2. That's my simplified final answer. My denominator is not allowed to be what? I take x plus 2. Cannot be equal to what? 0. What do I need to do to both sides to get x by itself? Subtract 2 from both sides. So that means x can't be what? X can't be negative 2. I want you guys to do the check problem right below example number 2. We'll go over that together in right about 5 minutes. I'm going to give you 5 minutes to do that one. Hold on, I'm coming.
Oh, it was just the same. Like, see? Like,
No, I'll say x is not allowed to be equal to, or it might say the denominator can't be.
wait,
First thing you always look for.
can we do that by negative?
Is that the base?
This is a positive.
Divide that by a negative 2, that's 4 divided by negative. There you go.
Okay. After we find out GCF, what are you supposed to do with it?
You got to take it out, bring it out to the front, like that.
Oh, okay.
If you got it out of the top, it'll stay on the top. If you got it out of the bottom, it'll stay on the bottom.
So this is
Mm-hmm. Nope, can't leave it like that. You have to factor it. Look at example number, or example B from yesterday, page 3. Mhm. Mhm. It's always what's on the bottom. Mhm. What does it have? An A.
And a B, C.
How do you know whether it's A, B, or C?
If it doesn't have like a textbook one.
Which is which? Because they're always very specific about that. So is it B or is it C?
C.
It's a C. This will factor. Look at example B from yesterday on page 3. Mm-hmm.
The square root of x to the second power is x.
Mm-hmm.
So it's just 2 and then 1 is just 1. Like.
Do you have X and X in here?
There ain't no B. I put 0.
Mm-hmm. So what are two numbers that you can multiply together and get -1? No, I gave you a positive 1. You want a -1. There you go. Yep, that's your two numbers.
Oh,
Yes. Yes.
ooh.
And write that out. That's not right.
Oh, you said.
You didn't take out your GCF. You wrote it down, but you didn't actually take it out. Divide it out. Divide this by -2. Divide this by -2. Divide this by -2. Does the numerator, does the top have a GCF? What is it? -2. That means up on top, I have a -2 there along with whatever other factors I might find. I have to take that GCF out of each of these pieces. So I would have -2 times, what would I have left if I do -2x squared divided by -2? Just an x squared. What about 2x divided by negative 2? Negative x. 4 divided by negative 2? Negative 2. So my A, my B, and my C. A is 1. B is negative 1. And C is negative 2. So I have x squared and negative 2 that go in my area model. I multiply those two numbers together, 1 times negative 2. Two numbers that multiply to give me negative 2, but when I add those same two numbers together, I get negative 1. Negative 1 and positive 2. If I add those, will I get a negative 1? Nope. So what would my two numbers be? Negative 2 and positive 1. Now if I add them, they're going to add to negative 1. So negative 2x, positive 1x. Multiplies to negative 2, adds to negative 1. Yep, I get x minus 2 when I look at my columns. I get x plus 1 when I look at my rows. So my numerator would be negative 2 times x minus 2 times x plus 1. I had a bunch of people ask me about the denominator. Let's start with a GCF. Does it have a GCF? No. A, B, and C. What's A? 1x squared. What's B? 0. There isn't one. B is 0, which means this is C. Can you do this with an area model?
Yes.
You can. Is there another way that you can do a problem like this? Does anybody remember what we call it? Yes, difference of perfect squares or difference of two squares. When we factor a difference of two squares, how many factors will we get? 2. Always, always, always going to get 2. But what will be the only difference between those two factors? One will be a positive, one will be a negative. All right, so now I got to come up with these factors. I've got an x squared. Yep. X squared is x times x. So each of these gets an x. What times itself gives me 1? 1. 1 times 1. Right here. If you used an area model, did you get the same thing? X plus 1 and x minus 1? You can do it either way. They're both valid. Is anything going to cancel? What cancels for us? X plus 1 cancels. So fully simplified, what do I have on top? Negative 2, x minus 2. Do you have to have the parentheses around the top? Unless you distribute that negative 2, you have to have the parentheses in the top. What do I have on the bottom? X minus 1. Do I have to have the parentheses around the bottom? No. Can you put them there if you want to? Yeah. They have to be in the top. They do not have to be in the bottom. And very last piece. What is my denominator not allowed to be equal to? Cannot be positive 1 or negative 1? Positive 1. We take that denominator, x minus 1. Denominator is not allowed to be equal to 0. So I add 1 to both sides. X cannot be 1. You guys feeling okay about what we did today?
Yeah.
Biggest piece of it is factoring. That's why we practiced factoring yesterday. Factor, 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 and then factor some more. Give me just 1 second and then yes. All right. Last bit of info for today. Come on. Homework number 1, the one that I passed out yesterday for factoring, that's due today. If you don't have it with you today or you're not done with it, you can finish it up and turn it into me when you are done with it. If you've got it, turn it into the review side up here. Homework number 2, which is on McGraw-Hill. Homework number 1 is the only paper homework. I know. McGraw-Hill for homework 2, it's due on Thursday. We've only done about half of what we need to know. We'll finish up the other half tomorrow. Okay? Do you guys have any questions for me? Cool beans.